Alright guys, so this is lesson 8-2 practice, and this has to do with just a bunch of adding, subtracting, and multiplying and dividing with imaginary numbers. Okay? Alright, and basically when you're dealing with imaginary numbers, you can treat them as if they're variables, except you have to realize that I is equal to the square root of -1, which means that I squared is equal to -1. So if I took I times I, which is square root of -1 times square root of -1, then that's equal to -1. So whenever you get an I squared, you can substitute it with a -1. And I should say if you ever get an I squared. So let's go ahead and do these problems. So for number 19, we'll go ahead and add, and these are pretty basic. You're just going to combine like terms. Okay, so 6 minus 2 would be 4. And then -5 plus I plus 6I would be plus 1I or plus I. Okay. B, same thing. So 4 minus 4 is 0. I plus I is 2I. So that's equal to 2 times I. Here we've got negative, so we got to distribute this thing. So negative and then plus. So 5 minus 3 would be positive 2. And negative 3I plus 5I would be plus 2I. Next up here, we are going to, again, distribute the negative. So plus, minus, and minus. All right, so this one, since we're dealing with some fractions here, we've got to do -3 minus 3 halves, which is the same thing as -6 halves minus 3 halves. Okay, changing that 3 into the 3 over 1 into a common denominator of 2. And let's go ahead and do the other ones too. So this would be plus 16I over 2, changing that 8I, 8 over 1I to 16 over 2I, and then minus 1 over 2I. All right. And by the way, if the i's in the top or on the side, that's the same thing. And actually, let me put this down here because we might use this space later. So this is going to be equal to -9 halves and plus 15 halves I. All right. Alright, so number 20. Alright, so multiply. Write each product in the form of a plus bi. So this is the complex format of a number, a plus bi. The real part is a, the imaginary part is bi. Alright, so when we multiply these things out, looks like, how much room do I have? Oh, I got tons of room. Okay, so let's go ahead and do these over here. So 20, and we'll do a. So a is going to be double distributing here. You have 6 minus 2i plus 27i and minus 9i squared. And remember, this I squared here will become a -1, so that would be a positive 9. So 6 plus 9 would be 15. And then -2i plus 27i would be plus 25i. All right, let's go to B. All right, B is going to be -5 plus 8i times 2 minus I. So let's go ahead and double distribute again here. So I got -10 plus 5i, and then plus 16i. That's 8i times 2. And then minus 8i squared. Again, that I squared becomes a -1, so that would be positive 8, so I'm left with -2 plus 21i. Alright, let's go to C. And C will multiply here again, double distribute. So I've got 8 times 8 is 64. And what is 8 times 15? 120, I think. Let's see, 8 times 15. Yep, 120. So I've got minus And by the way, if you can't tell, this is 8 plus 15i, 8 minus 15i. So technically, these middle terms are going to cancel out if you could recognize that right away. But let's go through it. So that would be minus 120i, and then 15i times 8 would be plus 120i, and then 15i minus 15i should be 225. Let's make sure. Yep, 225. So minus 225i squared. Again, that's going to turn into a positive there. These guys are going to cancel, negative 20i plus 20i. So we are left with 64 plus 225, which would be 289. And it does say write it in complex form, a plus bi. So this is actually 289 plus 0i. Okay. All right, and then finally D. Let's see, so multiply, just distributing the 5i in there. So we got 40i minus 20i squared. And this becomes a negative, so I have 20 plus 40i in a plus bi format. All right, so let's go down to 21. So we're going to divide these, and yeah, these are going to require a little bit of work here. So we'll say 21, put a little line going across here. All right, so number 21, we cannot have an I in a denominator because the I is equal to the square root of a negative 1, and I cannot have a square root or a radical in the denominator. So we have to get that out of there by multiplying by the conjugates, okay? So the conjugate in this case would be 4 plus I. Got to multiply top and bottom by 4 plus I. And the reason why we can do that is because when we multiply by 4 plus I, that is equal to 1, right? Anything over itself is equal to 1, and we can definitely multiply anything by 1 if we want to. So let's go ahead and do that. So the top is going ahead and double distributing here. I will get 4 plus I plus 16i plus 4i squared divided by, and what's going to happen here when we multiply by the conjugate is the middle terms will always cancel, and the I will turn into a negative I squared, and that'll turn into a negative 1. So we should always get a whole number in the denominator here. I'm not going to rewrite all of these, but I'll do the whole thing for this first one. So I have 16 minus 4i, I'm sorry, plus 4i, and then minus 4i, and then minus I squared. So this whole thing becomes, because here's a I squared and here's an I squared, so that will turn into a minus 4. So I have 4 minus 4, those are going to cancel, and then I plus 16i, so I have 17i divided by, and now these are going to cancel, the 4i and negative 4i, and negative 1i squared is going to be positive 1, because it's going to switch to a positive. Negative 1 times negative 1 is positive 1, so that's over 16 plus 1 is 17. So 17i over 17 is equal to I. Oh, and it does say write it in a plus bi format, so let me rewrite that. That would be 0 plus I. And that is 21a, so let me put a on there. And now let's go to b. Alright, so b, I'm going to multiply by the conjugate here, so in this case I'll put my work over here, start it over here anyways, 3 plus 4i, 3 plus 4i. Alright, and so when I multiply this out, I will get negative 6, and then that is minus 8i, and then plus 15i, and plus 20i squared. Alright, all over, and this time I'm going to do a shortcut here because I know that this is just going to be, when the middles are going to cancel, so I should just get a squared and then b squared. So that would be 3 squared, which is 9, and then minus 4i times 4i, which is 16i squared. All right, and so let's go ahead and simplify this. So this I squared here is going to be -1, and this I squared is going to be -1 as well. So that will become -6 minus 20, so -26, and then plus 23i divided by 9 plus 16, so that would be 25. All right, and rewriting this in a plus bi format would be negative, don't have a lot of room here, negative 26 over 25 plus 23 over 20, yeah, I don't have room. Let me undo all this, sorry. We got plenty of room on the paper, let's use it. So that will be equal to negative 26 over 25 plus 23 over 25i. Oh, and I'm just checking my answer here, and it looks like I did something wrong here, and let's take a look. That is a negative 8i plus 15i. I thought that was a positive 8i, saying coming up with 23i. But anyway, negative 8 plus 15 should be positive 7. So let's go ahead and fix that real quick. So that will change this to plus 7i. Sorry about that. And plus 7i. All right. Okay, let's go to C. And C, let's see here. What is the, if I had, for example, like this is equal to 7 minus 3i over square root of -1. If you had the square root of anything, you would just multiply by square root of -1, right? But I also want to show you that you could do it like this. You could say, I'm not going to do it like this, but you could also say that if this was in complex format, that would be 0 plus I. So you could multiply it by 0 minus I. You'd have a negative to deal with, but it would work out the same, okay? But in this case, I'm just going to multiply top and bottom by I, making this I squared, and then you'll get a -1 in the bottom. That will have to move up to the top. But again, either one works. So let's go ahead and do that. All right, so I have distributing the I into the top, I would have 7i minus 3i squared. And then into the bottom, I will just get I squared. So this is equal to, let's do 3. This will turn into a positive 3. So 3 plus 7i, switching those around to be a plus bi. And then I squared is just -1. So now to distribute it to the top, I'll multiply top and bottom by -1. So I'll get -3 minus 7i. All right, there we go. All right, let's go down to number 22. Let's see here. They want us to use substitution to show that the solutions of the equation x squared minus 4x plus 20 is equal to 0 are x is equal to 2 plus 4i and x is equal to 2 minus 4i. So they want us to use, there are a lot of ways to show this. They want us to use substitution. Basically, I'm going to have to substitute each one of these in here to show that we end up with 0. So let's go about doing that. Let's see, and this is going to take up, I think, a significant amount of room, so let's go ahead and do that. So the first one, I'm going to substitute 2 plus 4i. So if I substitute 2 plus 4i for x squared, I will get 2 plus 4i squared minus 4 times 2 plus 4i, substituting the x there, plus 20, and I want to show that this is equal to 0. So let's go ahead and do that. So squaring this whole thing, you cannot just distribute this squared in here. Remember, this is the same thing as 2 plus 4i times itself. So it's 2 plus 4i times 2 plus 4i. So you'd have to double distribute, or FOIL in that case. So I will do that, and that should be 4 plus 8i plus 8i is 16i, and then plus 16, 4 times 4 is 16i squared. Okay, so that's what I get over here. And then minus, I'm going to go ahead and distribute. Actually, I could probably get rid of these parentheses. And then I'm going to distribute the -4. So that would be minus 8, and then minus 16i. Okay. I'm sorry, plus 20. Don't forget about that plus 20 hanging out there. All right. So this I squared here is going to become negative, uh, negative 1, and these 16i and minus 16i, these are going to cancel. So actually, let me go ahead and use a different color so we can see that. So this guy will cancel, and this guy will cancel, and then this becomes a negative 1. Okay, so let's go ahead and do that. So I get 4 minus 16 minus 8, and then plus 20. All right, let's go ahead and simplify this further. So 4 minus 16, we'll do both sides here, I guess. So 4 minus 16 would be negative 12. And then negative 8 plus 20 would be positive 12. So this becomes 0. And there you go. All right, now let's do the other one here. So the other one is I'm going to substitute 2 minus 4i to show that it is also a solution. So do the exact same thing. So this is 2 minus 4i squared, and then plugging in the x here, so minus 4 times 2 minus 4i, and then plus 20. All right, so go ahead and double distribute here, so you'll end up with 4 minus 8i minus 8i, so minus 16i, and then negative 4i times negative 4i will be positive 16i squared. And then distributing the negative 4 here will be negative 8, or minus 8, and then plus 4 times 4 is 16i, and then plus 20. All right, so let's go ahead and same thing here. Let's see here, I've got a minus 16i and a positive 16i, so those are going to cancel, and I've got an I squared, so that will become negative 1. So I am left with 4 minus 16 minus 8 plus 20. 4 minus 16 is negative 12, and negative 8 plus 20 is plus 12, so that becomes 0. Negative 12 plus 12 is 0. And there you go. All right, let's go to the next one here. Number 23, what is the sum of any complex number, a plus bi, and its conjugates? All right, so let's go ahead and we'll put that one right here. So 23. So a plus bi plus its conjugate, a minus bi, is equal to, well, these guys are going to cancel. Boom, boom. And so you're just left with 2a. All right. All right, and then finally number 24, last one here. Explain how to use the commutative, associative, and distributive properties to add complex numbers 5 plus 8i and 6 plus 2i. Okay. This should be interesting. So let's go ahead and add these. So I have 5 plus 8i. And I'm going to add 6 plus 2i to that. All right, so commutative means I can move these things around. So I'm going to move the 6 with the 5 and the 8i with the 2i. So that means that I have 5 plus 6 plus 8i plus 2i. So we'll call that bicommutative. If I could spell commutative. Property. All right, and with the associative, that means that we can group these together. We are associating like terms. So I'm reassociating. So 5 plus 6 plus 8i plus 2i by associative property. And then finally, the distributive property, and actually we're going to, it's actually like we would call it the GCF, the opposite of the distributive property. Basically, both of these have i's, and I'm going to, instead of distribute it, I'm going to do the opposite of distribution. So let's go ahead and do that. So this would be 5 plus 6 plus, and I'm going to pull it out, not in front. I usually goes behind numbers, so I'll say 8 plus 2, and then I'm pulling it out in the back side here, so 8. And this is by the distributor property. And then finally we can go ahead and add these up. So this would be 11 plus 12i. All right. And that basically, you know, yeah, going through every single little step to show why we treat I like, almost like it's another variable. Okay. Yeah, so that looks like it's the last problem here. So let's zoom out a little bit so we can see everything. And there we are. That finishes lesson 8-2 practice.